Good evening. Mm, So, in this lecture, we will discuss Kruskal algorithm. Before Kruskal algorithm, I think in the last lecture we discussed the Prim's algorithm. I think I explained a method using this, uh, uh, okay, using this table. Okay, so there is a slightly different method is also available for Prim's algorithm. So maybe I will explain that one quickly and then I'll go to Kruskal. So find the minimal spanning tree of the weighted graph using Prim's algorithm. So this is the graph. It is given the question. Okay. So from this graph, you need to draw this matrix. So you know how to write this matrix. Okay. So V1 to V. Okay. So already I explained two problems. So that's why I don't want to spend more time to form the matrix. Okay. So here the matrix is here. Now, first step one, select an arbitrary vertex. Okay, either you can choose V1 or you can choose any vertex. I'll choose V5. Okay, and yeah, I choose the vertex V5 and select an edge with the minimum weight incident with what? V5. So what is the edge with the minimum V5? Okay, wow. So 9 and 4. So here V5, V6. Okay, or here we have 4. Okay, wow. Similarly, uh, yeah, V5, V2 is also what? V5, V2 is also 4. V5, V6 also 4. Okay, so already I drawn the diagram. Okay, wow. So that's why I'll choose what? V5, V2. So then I can easily explain the problem. Or you can choose, if you want to choose, you can choose V6 also. Okay. Now, okay, select an arbitrary vertex, say V5, and select an edge with the minimum weight incident with what? V5. So you should draw the diagram like this, and then you should cross it out like this. So because I choose this one. Okay, I choose this one. First step one. Okay, wow. So you should draw this graph V2, V5. This is step number one. Okay. Next, step number two. Select an edge with the minimum weight incident with the V2 or this is not and either V2 or V5. So now V2 or V5, I am going to check which is minimum. Okay, wow. V2 or V5. So V5, what is minimum here other than this one? Because already crossed one. Okay, uh, okay, V4. This 4 you can choose. Okay, wow. Then V2. V2, okay, again I have 4. Either you can choose V2, V5, or you can choose what? V5, V6. There are two options because both of them are what? 4. Okay. So, because we need to consider only what? These two vertices, V2, V5. So, select an edge with the minimum weight incident with what? V2 or V5. So, here there are two options. Already told to you. V2 to V5 is what? 4. V5 to V6 is what? 4. So, you can choose any one. So, I think they are choosing what? V5, V6. Okay, that's why I'll choose V5, V6. I will put a cross here. Okay, I choose this one. And then the step two, you should draw. Already, this is what? V2, V5. Now, V5, V6 is what? V5, V6 is 4. Okay, I draw like this. Next, select an edge with the minimum weight incident with what? Either V2 or V5 or V6. So now you should check these three vertices. Okay, V2, V5, V6. V2, okay, V2, V5. Okay, V2, V5. Already we choose the yes because V5, V2. Okay, V5, V2 already choose to means V5 also we can't choose again. Similarly, V5 V6 is 6 means V6 V5 also you cannot choose again. Okay, now how many vertices? V2 V5 V6, V2 V5 V6, V2, okay, V2 V5 V6. So out of these three, okay, which is minimum? Pi is minimum. Okay, in this row, V2 row, V5 row, V6 row. Okay, so 5 is what? Minimum. So we can choose V2 V1. We'll check it. Can choose V2 V1. Yes, we'll choose V2 V1 and draw the diagram. What is the weight of V2 V1? V2 V1 is what? 5. Okay, that's why they'll put here 5. So here I cross it out V2 V1. Similarly, V1 V2 is also you can cross it out. Now we have 4 vertices. The step 3, V1 V2 V5 V6. Now V1 V2 V5 V6. V1 V2 V5 V6. Among this, I think the what is the minimum? Minimum is 6. I think so. Okay, V2 V1 V2 V5 V6. Minimum is there are 2 6. One is V2 V3. Another one is what? Another one is V6 V4. Okay. V2 V3 or what? There are 2 options: V2 V3 or V6 V4. V2 V3. V2 V3. Okay, or another option is what I told. V2 V3 or V6 V4. Okay. V6 V4 also you can put. Okay, do not form a cycle. Or one more option, V2 V3. V2 V3 is also you can choose. Okay, I choose V2 V3. V2 V3. Okay, what is the weight of V2 V3? Weight of V2 V3 is what? 6. Okay, similarly V3 V2 is what? 6. You can cross it out. So I'll put here 6 is V2 V3 6. V2 V5 is what? 4. Okay, already it is there. Okay, now we have 5 vertices. Okay, V1, V2, V3, V4, not V4, V5, V6, except V4, remaining everything is here. Okay, except V4. So V1, V2, V3, V5, V6. I think again, I think 6 is the minimum. Okay, you can check it. So either you can choose what? Except the row V4. Okay, V1, V2, V3, V5, V6. 6 is minimum, that is what? V6, V4. So V6, V4, yes, we can choose because it will not form a cycle. So that's why we are drawing in each stage. We should draw a graph. Suppose if we don't draw the graph means if the cycle forms means we don't know. Okay, so if you draw the graph in each stage, then only we know whether the cycle is forming or not. So V6 V4. Okay, next edge. Okay, yes, here next step. So select an edge with the minimum weight incident with what? V1, V2, V3, V5, V6. Select what? V6, V4. So V6, V4 weight is what? 6. Okay. So now I'll put a cross mark. Just V6, V4 is what? 6. V4, V6 what? 6. I think how many vertices? 6 vertices. Check it how many edges you have now. 1, 2, 3, 4, 5 edges. So it is connecting all the 6 vertices V1, V2, V3, V4, V5, V6. Now this is a spanning tree. So this is a spanning tree with the total weight of the spanning tree. You should add the edge weight. So 4 plus 4 plus 5 plus 6 plus 6. So totally 25. So this is another method. So you can follow any one of the method. The previous method you can follow, or you can follow this method. Okay. Next, Kruskal algorithm. So in Kruskal algorithm, the edge of the given graph G are arranged in the increasing order. or it is in ascending order. Okay, uh, an edge G with the minimum weight is selected as an edge of the required spanning tree. Edges with minimum weight that do not form a cycle or circuit with the already selected edges are successfully added. The procedure the procedure is stopped after n minus one edges have been selected. Okay, so Prim's algorithm already be discussed. So some of the notes, maybe this note is already be discussed. Okay, the weight of the minimum spanning tree is unique. Okay, so the weight of the minimum spanning tree is unique, whereas different spanning trees are possible, as two or more edges can have same weight. Okay, in Prim's algorithm, edges of minimum weight that are incident on a vertex already in the spanning tree. Okay, and not forming a cycle are selected. Whereas in Kruskal algorithm, edges of minimum weight, okay, that are necessarily incident. Okay, that is most important. That are necessarily incident on a vertex already. Okay, in the spanning tree, that is not forming what a circuit or cycle are selected. Okay, so for this problem, find the uh, minimum spanning tree for the weighted graph. Okay, just I'll take a snapshot and then I'll put it in the. Okay, so actually in the question they gave what this diagram with the minimum weight. So first step you should do arrange the weight uh, in the ascending order like this. Okay, and also you should write the edges. First these two steps you should do it. Next, whether we need to include the edge in the spanning tree or not. Here you should write yes or no. Just okay. If not included in circuit formed, you should write the reason. Suppose here I'll put no. Okay, I'll come to step by step. So first I'll choose what? The edge what? This is A. This is A. Okay. Now minimum weight. A is what? 2. I'll select. So that's why I'll put yes. So in this stage, you should write in your wording. So select edge with the minimum weight. I'll choose what? AE. So in the first step, you should draw this diagram. Step 1. Okay. You can write a line or on line. So select an edge with the minimum weight AE. Okay, and then you should write. And the next CD is what? 3. Okay, in step 2 again in step 2 CD means this one. Okay, this is what? This is weight 2. CD is what? uh, CD is 3. This is step 2. In step 2 you should draw both the graph, both the diagram. Okay, both this edge as well as this edge. Okay, next here we'll put what? Yes, because we are taking that edge. Next to 4. Okay, AC. Okay, 4 AC. Yes, you can join AC, no problem. It will not form a cycle. So AC is what? 4. So first 3 yes. So now how many steps are over? 3 steps. So uh, okay, 3 steps are over. You should draw 3 diagrams separately. This is the third diagram. Okay, this is the third diagram. Next, CE4. So I cannot add this edge C. Then because why it is form a cycle? Okay, that's why I'll put what? No. Yeah, it will form a cycle. A, E, C, A. It will form a cycle. That's why I don't want to take C. Next I'll go to 6. 6 is what? AB. Yes, I can take AB. This is step 4. A, B, weight is what? 4. This is the fourth step diagram. So here I will select AB. Okay. The weight is what? AB is 6. AB is 6. Okay. And then BC. Next to 6. Okay. 6. BC. So again, if I put BC, it will form a cycle. That's why I don't want to take this one. The reason you should write. So A, B, C, A, it will form a cycle. Okay, I think this step is not needed even, because the reason is why it is not needed, because 5 vertices 1, 2, 3, 4, 5. So 5 vertices means 4 edges is enough. 1, 2, 3, 4. So I got a spanning tree. So why should I go for the next step? Okay, up to this is enough. Okay, up to this, but you should write all the edges. Okay, that is most important, because I don't know where it is stop, where it will stop. Okay, but my suggestion is there is no need to write what this uh, 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 these two things. I think this is not needed from my point of view, because I got what? 4 edges. 1, 2, 3, 4 edges I took already. How many vertices? 1, 2, 3, 4, 5. So this is a required spanning tree. So total weight is what? 10, 15. You can check it. Yes, 15 is the uh, since there are 5 vertices in the graph, we should stop the procedure for finding the edges of the minimum spanning tree when 4 edges have been found out. The edges of the minimum spanning tree are, you can write the 4 edges. Total length is what? 15. So there are 5 other alternative minimum spanning trees of total length is what? 15. It is listed below, so you can check it. Okay, so we need to find one. So still 5 more are possible. The reason why it is 5 are possible means here you have what? 4, 4. Okay, here also what? 6, 6. Suppose maybe somebody will write uh, uh, BE first, and then AB, and then what? BC. Somebody will write BC first, and then BE second, and then AB. Okay, it depends upon how they are writing, because all of them are 6 means. Okay, so you will get more options. Okay, so that's why you will get more uh, different spanning trees, but the weight is what? Same. Okay, so next I will go to this column. So I'll take the snapshot. So use Kruskal algorithm. Uh, find the minimum spanning tree for the weighted graph shown in this figure. So this is the explanation. Here it is given. Okay. So now, so again, the first thing what you need to do, first you should write the edges with the ascending order. The weight of the edges should be in ascending order. You should write it clearly. So first 2 columns you should write. Okay. Next, I'll choose EF, first edge. Okay, I don't, totally how many vertices? 9. I need to choose what? 8. So EF means, okay, I'll put it EF like this. EF. This is step number 1. Right is what? 1. Next, AD. AD. Okay. So here, next, AD. Step number 2. You should draw both the edges. AD weight is what? 2. Next, 2 HI, HI, HI. What is the right? 2 HI is okay. I included. This is step 3. So step 3, all the 3 edges should be there in the graph. Next, 3 E B D, B D. Okay, here. Okay, B. Sorry, here B. Oh, okay, sorry. A D, A. I put A B here. A D. This should be what? A D. Next, now I told what? B D. This is B D. Okay. B D. What is the weight? B D weight is 3. Okay. So no problem. B D I selected. Okay. And the next 3 is what? C F. C F. C F is what? 3. Okay, I selected CF. Next, EH. EH is 3. Yes, I can choose EH also. EH is what? 3. Selected. Next, 4. BC. BC. Yes, I can choose BC also. BC is what? Weight 4. How many tick? 1, 2, 3, 4, 5, 6, 7. Okay. So totally 9 means I need one more edge. Okay. So next, 4 FH. FH is what? FH means, okay, if I take FH, okay, it will form a cycle. Okay. So you can write FHEF, or you can write what? EF, EF, uh, EF, HE. It will form a cycle. That's why I don't want to choose. That's why I put what? No. Okay. Next, F4, F5. So F5 again it will form a cycle. So you should write which one, what is the cycle it will form? E F I H E. Okay, E F, yes, E F I H E. So it will form a cycle. That's why I don't want to choose what F5. Next, I need one more again, 4 GH. G, here you have what? G H. So what is the weight of GH? 4. So now I think you have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 edges. I think it is connecting all the vertices A to, I think, A to I. Okay. So this is a required spanning tree. The total weight, 2 plus 3, 5, 5 plus 4, 9, 9 plus 3, 12, 12 plus 1, 13, 13 plus 3, 16, plus 4, 20, 22. So I'll check the answer, 22. So yes, 22. And I should write the required minimum spanning tree consists of 8 edges. And what is the edges? You should list out those edges, and and write the total length of the minimum spanning tree. So these two are important, and the diagram is important. And each stage you should draw a diagram. Okay, that is most important. Okay. So look at this graph again. Show how Kruskal algorithm find a minimum spanning tree for the graph in the figure. Also find the cost of it. So here they gave a diagram. Okay. So the problem is again as usual. Okay. So I think I explained 2 problems, and that is enough from my point of view. So those who are interested, okay, uh, take this problem, okay, and write first ascending order, and write the edges, and then here I done it. The steps of for finding the minimum spanning tree are given below. First, you should choose what? One means what? BC. BC means this edge you should choose. So choose the edge. So this is the way you should write. Step 1, or put 1. Choose the edge BC as it is, as it has a minimal weight. So BC 1. Next, here we have one C. So add the next edge C. Okay. So here I'll put C. Weight is what, 1. Okay. Next, step 3. 2. CD is what, 2. CD. Okay. So add the edge CD. CD is what, 2. Next, 3 steps are over. Next to 3. AB is 3. Yeah. Okay. Add the edge AB. AB. I don't get the cycle. That's why I'm adding. AB is weight 3. Okay. AB is 3. Now how many vertices? 1, 2, 3, 4, 5 vertices means 4 edges is enough. 1, 2, 3, 4. I think all the vertices we have A, B, C, D, E. Since vertices are 5 and we have chosen 4 edges, we stop the algorithm and the minimal spanning tree is this is the minimal spanning tree. What is the weight? 3 plus 1, 4, 5 plus 2, 7. So minimal spanning tree. Cost or weight of the minimum spanning tree is what? It is better to write one. Don't write directly 7. Okay, write like this: 1 plus 1 plus 2 plus 3 equal to 7, and also this is the minimal spanning tree. Okay. Here the next problem. Okay. Here this is the this is the diagram is given the question. Again, you should write the weight in the ascending order. Okay. Here, what is the first minimum one? 1. So AC. So choose the edge with minimum weight AC. Okay. Next, 2 BD. Add the edge BD. So first here AC and then what? AC. AC is like this. BD. BD is what? Like this. That's why I'll put what? BD. Weight 2. Next, 3 EG. EG means okay. Again, add the edge EG. So EG is somewhere else here. So that's why I'll put I'll add EG the edge. Okay. Next, after EG, you have 4. 4 is what? BE. BE, where I am going to add BE. Oh, yes, BE. Yes, BE. Here you should add. Okay, B is here, E is here. So BE I add here. B is 4. Next to 5. DG is 5. DG, okay, I cannot add DG because it form what? Cycle. So reject the edge. Okay, DG since it forms a cycle. Okay, it's step number 5. DG is 5. Next to 6, DE. I'll check it. DE, again DE, if I draw here, again it will form a cycle. Step number 6. So reject the edge DE since it forms what? A cycle. Okay. So next DE, okay, DE, okay. Next is 7. DC is 7. Yes, I can draw DC. Okay, it will not form a cycle. DC is 7. So add the edge DC. DC is what? Weight 7. Okay, next DC 7. Next 8. AD is 8. AD. If I AD means it will form a cycle. That's why I should reject the edge AD since it forms a cycle. AD. Okay. AD. Next AD after AD 9. AB. AB again AB forming a cycle. So reject the edge since it forms a cycle. So I also reject AB. Next to DF 10. DF. DF is somewhere else here in the original graph. So that's why I draw. It will not form a cycle. Weight is 10. Okay. So now, how many vertices you have? Totally 7. 1, 2, 1, 2, 3, 4, 5, 6, 7 vertices means I need 6 edges. Check it. 1, 2, 3, 4, 5, 6. Okay. So I think and one more thing should check whether all the vertices are here. A, B, C, D, E, FG. Yes, I think yeah, up to A to G. Okay. So this is the required spanning tree. Wait, you should add it. Since vertices are 7, we have to choose on 6 edges. So we stop the algorithm and the minimal spanning tree is produced. This is the minimal spanning tree. The weight or cost of the minimal spanning tree, you should write what? 1 plus 2 plus 3 plus 4 plus 7 plus 10 equal to 27. Add and write. Okay, so I leave this problem to you. Okay, it has 12 vertices, so you need to find 11 edges. Okay, so again this problem contains 8 vertices, you need to find 11 sorry 7 edges for this problem. Okay, so this problem is slightly different, but this is the last problem uh, in Kruskal. So how it differs from the other problems? Here they don't give the graph. Remaining all the problems they gave this graph, you can easily write the table. Okay, but here they write okay, I read the problem. 8 cities A to H are required to connected by a new railway network. The possible tracks and the cost of involved to lay them in crores of rupees are summarized in the following table. Track between A to B, so their cost. So, so there is no space like this here. That's why they write here. Okay, track between, and then cost. Okay, here from this data, okay, determine a railway network of minimal cost that connects all these cities. First, you need to draw the diagram, draw the graph from the data. So A to B is what? 155, right? Next to A to D, 145, A to D 145. A to G is what? 120, A to G is 120. B to C is what? B to C 145. C to D, C to D 150. C to E 95, 95. Next to D to F 100, D to F 100. E to F, E to F, E very E. Yeah, E to F is what? 150. F to G, F to G 140. F to H 150. F to H 150. G to H 160. So once you uh, draw this graph, next step you should write in the ascending order. Okay, so what only this diagram is given. Instead of this diagram, they give this data. So from the data, if you draw the graph, the next step you should write like this. Okay, you should write in the ascending order like this and write. So the final answer I mentioned here. This is the required spanning tree. Okay, uh, the uh, the cost of the network also I mentioned 95, where 95, 100, and then 120, 120, and then 140, 145, and then 150, 150. So if you add everything, you get 900. It's in crores of rupees because they gave in crores of rupees. The 900 crores of, it is in crores of rupees. This is a total cost. Okay, minimal cost that connect all these cities. This diagram, as usual, you should do what? Step one, you should choose this edge. Step two, add this edge. Similarly, you should write. So one can easily uh, try to solve this problem and verify the answer. Okay, thank you. I'll stop here.